This lesson introduces functions along with several methods for determining whether or not a relation is a function. We start with the definition of a function. A relation in which each x-coordinate is matched with only one y-coordinate is said to describe y as a function of x. The set of ordered pairs 4, 1, 3, -2, 7, 2, and 2, 4 is a function since the x-coordinates 4, 3, 7, and 2 are each matched with only one y-coordinate. In this second set of ordered pairs 1, 3, 1, 4, 2, 7, and -4, 6, the x-coordinate of 1 is paired with y-coordinates of both 3 and 4. This is not a function. The set of ordered pairs 4, 1, 3, -2, 7, 1, and 2, 9 is a function. It's okay for two different x-coordinates, 4 and 7, to be paired with the same y-coordinate of 1. It would not be okay for the x-coordinate 4 to be paired with both 1 and 3. The vertical line test. A set of points in the plane represents y as a function of x if and only if no two points lie on the same vertical line. For this first graph, we can see that any vertical line we draw will only pass through the graph one time. Thus, this first graph is the graph of y as a function of x. The second graph, we can draw a vertical line through the graph that passes through the graph more than once. This second graph is not the graph of a function. The third graph contains a finite set of points. Notice that the vertical line x equals -2 passes through the graph more than once. This is not the graph of a function. Does the equation represent y as a function of x? This first equation is 2x squared minus 3y squared equals 6. We begin by solving for y. I'll subtract x from each, I'll subtract 6 from each side, and I will add 3y squared to each side. Divide through by 3. And we end up with y equals plus or minus the square root of 2/3 x squared minus 2. The plus or minus makes me suspicious. I'm suspecting that I can find an x value that if I put in some x value, I'll end up with two different y values. But let's check just to be sure. Let's try the x value of 3. If we plug 3 in for x, we have y equals plus or minus the square root of 2/3 times 3 squared minus 2. Simplifying a bit gives us y equals plus or minus 2. One x-coordinate here is paired with two y-coordinates. This is not a function. Try this next example on your own. Does the equation 2x plus 3y equals 6 represent y as a function of x? Explain why or why not. One more example. Does the equation represent y as a function of x? This equation is 2xy cubed equals 6. Again, we'll start by solving for y. We'll divide both sides by 2x. We have y cubed equals 6 over 2x. And simplifying a little more, y equals the cube root of 3 over x. The cube root of a number is unique, so there will be only one y-coordinate matched with each x-coordinate. This relation is a function.